Hi, good morning. It's Jim from Mathstar Observatory. We've been discussing economics and the current climate that we're in at the moment, and I think it's time to go back to a bit of science and look at some of the real possibilities of things that will affect us in the near future. And in this video we're going to dedicate most of the upload to a CME, coronal mass ejection from the Sun, and what's the likelihood of that. You may have heard about the coronal mass ejection that took place around 1859 or thereabouts, and it was classified as the Carrington event. Just briefly, at the time of that event, the only technological infrastructure that was available in high tech in that day, I suppose you could say, was the telegraphs, and pretty much all of those around the world burned down as a result of that coronal mass ejection, which is a large electromagnetic pulse that is ejected off the Sun during a coronal mass ejection, comes through our atmosphere and directly affects electronics and other electrical components. If one of those happened today, it would pretty much send us back into the dark eras, because as you know, nuclear power plants are all run and built and designed around electronics. So the actuation systems that would run different cooling pipes and things like that would cease to work, because the mainframe that controls it would drop, and that could be very devastating globally, because these power plants are all around the world. Not just that, it's the avionics on aircraft. I know that there is some protection now on the newer aircraft, but there's still a lot of older aircraft that are flying around, I believe, that haven't had the modifications to cope with CCU strikes, which is what we would get during a CME, and that could be again devastating. But not just that, our everyday lives, where we rely on mobile phone technology, smartphone technology to do our internet banking, purchases, etc., which we are more heavily dependent on these days, would cease to exist. Another thing that would cease to exist would be the petrol pumps. They wouldn't be working in the local petrol stations. That means the logistics would break down. Also, the sewerage and water companies, again, same as the nuclear power plants, all heavily reliant on actuations driven by mainframe computer systems, would fail. So nothing would go into cities, and nothing would come out of them as far as waste and water and grey water and etc. And that would make cities a very stagnant place to live. But what is the real possibility in the short-term future of such an event happening? And if it isn't a real threat, then where do we stand with regards to the activity right now on the Sun? So before we get into it, I always like to thank people that are supporting what we do at this observatory. In some respects, we go against the grain, we go against mainstream science, and therefore we deliver an unorthodox view or an alternative view on these given situations. And I'm happy to do that, because it's my opinion based on the information I see. And although there is a lot of talk from these mainstream organisations that there could be in the next 10 to 15 years, a large event with regards to a CME coming off the Sun, I don't see that being the case, and I'll explain why. If we look here at the height of the solar cycle, 24, solar cycle maximum, we can see it occurred around 2014, 2015. And this was one of the lowest cycles we've had for quite some time. As you can see, the sunspot numbers have been dropping off. It's not just sunspot numbers that have been dropping off though. It is also, if we just pan down to the sunspot cycle and annual number of magnetic storms, it is also the magnetic storms that have been dropping off. And we are not, or we can see from the sunspot numbers, the level of decaying numbers from solar cycle 23 here, and you can see where we are, where the dotted line is crossing, the increase up to solar cycle 24. Well, we know that solar cycle 24 was a lot smaller than solar cycle 23. We can see that where this line ends here, it is almost at the peak of 2015, almost there. So for 2014, 2015, we're at the peak of the solar maximum of solar cycle 24, and you can have a look at the bottom of the blue lines here, and we can see the level of solar storm activity. It is extremely low when you compare it over the mean amount of solar storms going back to almost the Carrington event, 1865. So it is, in my opinion, and until we start seeing an increase in solar storm activity and an uptick in sunspot numbers, then we're not going to be facing any extreme coronal mass ejections off the sun, as far as I can see. This is my opinion based on the data that we have before us. So, that's one thing. That means, okay, that's good news, because we're not going to get a solar storm which is going to affect our electrical infrastructure. But there is another problem. In fact, there is another two problems that we've got to worry about. During low solar activity, we also have a reduced heliosphere. Now, in good, strong, regular, common solar maximums, we enjoy a nice, plump, inflated heliosphere which protects not just our planet but the entire solar system. And during low yields of sunspot numbers, that heliosphere shrinks back in on the solar system, so some of the outer planets probably don't have as much protection, but the shield, or the heliosphere that protects our solar system, is a lot weaker. And what that means is we get galactic cosmic radiation increase, which can act just as bad as a heavy dose of radiation coming off the sun. Adding to this fact, we have a weakened magnetosphere, so our primary and secondary defense against cosmic radiation is at an all-time low. And because we are going through a geomagnetic reversal at some point, possibly in the next 2-3 years, or 2 to 7 years, it's still on the cards unless we start to see an uptick in the movement of the magnetic pole and a rapid depletion over Canada, then we're not going to know where we are quite and when it's going to happen. But we know that at this level of migration, we know that we are getting close to that cusp where we could be leaving the strong field lines, entering the weak field lines. And if you've been watching and following us here, you know that once that happens, things start to speed up. So we do have a risk, even though that the sun's at a low output of activity, and that is because of the heliosphere shrunk and the Earth is going through a magnetic reversal, which means the magnetosphere is weakening constantly from this point, and things are going to slightly get worse as time goes on. And that could pose problems, because we wouldn't even need an X20 or an X10 classified coronal mass ejection. It would only need to be a moderate one to cause severe problems. But at the moment, we don't see even an increase at the trough of the pattern going back over time. Like the sine wave that we're looking at over the highs and lows of the solar maximums going back to solar cycle 11 on this chart. So until we start to see an increase from the equilibrium point, which is a common word we use a lot here at the observatory, and I think it's fair to use that, because until you start to see an uptick in something, you can't say then that therefore we are heading towards a specific scenario. If it continues to decline, you go with the trend. And at the moment, sunspot activity has been dropping off over the last 33 years, and so has the magnetic storms associated with things like CMEs been dropping off. And as you can see at this current point in time, they're at all-time lows compared to the mean across this chart. So for me, I'm not particularly worried about seeing the grid go down at this moment with regards to CMEs. I am concerned about the increase in cancers, increase in cardiac arrhythmias across damaging biodiversity across all the ranges on this planet. I am also concerned with a few other things, because there is many things that we follow on this planet. Our primary objection is to study the effects of the magnetic pole reversal, and that can take us into pretty much everything else. We can look at the causes so far to date with the climate, and in particular we'd be focusing on the jet streams. Let's go and have a little look at today's jet streams, just to change the chart to keep it, you know, a little bit more interesting for you guys. Just bear with me. So here we are, taking a look at the jet streams today and the condition of them. And you know, we've had pilots confirm in just the last 10-20 years the unpredictability of the jet streams. Sometimes they're giving the jet stream forecast before long haul flights, and the jet stream has changed during that flight. So during, you know, 8-hour flight, 9-hour flight, the jet stream patterns have changed, and they've had to implement the journey to, you know, take into consideration these changes. I've had first-hand accounts talking to pilots where they have set off in the morning with the fuel load for the journey. They've had a heavy you know, headwind as a result of a change in jet stream, and therefore, you know, even though at this particular occasion they didn't have to divert to another airport to take on more fuel, they did have some concern about the levels of fuel on board, and if the case was to get worse, then that might have to be a decision that they had to, you know, put into factoring during that flight. So we know the jet streams have changed. One of the things that's changed about the jet streams, and I'll talk about the reason why they've changed, is but one of the changes that has happened in jet streams is they've become more laden with water. It's made them more sluggish, and the other noticeable thing is that they are no longer where they should be, 30 degrees north and south and 60 degrees north and south. So we've got the subtropical and the polar jet streams now intertwined with each other, and that is what is changing the climate. Because, you know, when you move 30 degrees the polar jet stream into the subtropical jet stream, and you get that polar temperatures speedily come down over a continent, you know, you can have things like floods, droughts, snow accumulation, ice weather, and you know, across the range you can have a lot of these scenarios take place. But the reason why the jet streams have changed initially in the first place is because of the extra inbound cosmic radiation that we've experienced over the last 30 years. You know, 30 years ago we wasn't concerned so much about climate, and that's because it wasn't affecting the seasons of crops. I mean, as a result of climate change today, and I'll just spin round the earth so we can see it. So when you're seeing this, guys, you know, it might be out of sync. That's because the recording rate of video and audio are at slightly different rates, and that's so that we can not take up too much bandwidth when we're uploading, and we get it up to the internet very quick. But you know, I'm pretty sure you'll follow. So we'll just take a quick look around the earth at the condition of the jet streams, and this is a classic example here on the southern hemisphere of our earth. There's a super jet stream, just, you know, covering thousands of miles in diameter, and you can see, you know, from the subtropical region right up into the polar jet stream, from the polar jet stream right up into the subtropical, we are getting movement of cold air, and after it passes the peak of the sine wave, it comes right back down into the trough right below Australia, you know, taking that warm humid air with it into the polar regions. And when that happens, we usually get precipitation. So, you know, we could expect Arctic snowpack to build up in those conditions. So, you know, cosmic rays, you know, account for a lot of water in these jet streams, and widening the jet streams, lengthening the jet streams, and making them more sluggish and bend down into the subtropical regions from polar regions, and vice versa. And that's why now it affects us directly, because, you know, we notice sometimes there isn't crops that we'd normally get. Like some days there's no cucumbers in the shops, some days, you know, there's no particular salad packs or stuff like that, and that could be for a multiple amount of reasons. I mean, it could also be, is what we're struggling with now at the moment through COVID-19 on farms, is, you know, the migrant workers not being allowed to work and pick the veg. You know, there was a crisis earlier on this year with that being the case. But in general, you know, with what farmers are faced with today is almost a gamble because nothing is like it used to be 30 years ago, very highly predictable. A lot of other things have changed over the last 30 years, which could be to blame for this, and we have to factor in everything really when we look at the whole picture. Is the forcing of farmlands, the adding of chemicals now to the ground, so that the plants that are planned to go into the ground, just setting climate on the side. Just this is the normal practice now, and this is concerning a lot of farmers. I've directly heard from farmers expressing concern about this, where they no longer allow the land to lie up for recovery, so that the natural meadows seeds that they put in the ground to get the meadow grass, which fixes nitrates and other chemicals into the ground naturally, doesn't occur. So what they have to do in order to do that, because it's not like they get a holiday period in any case from the mortgage, so what they do is they bang in the chemicals that the products they're designing to grow in that year into the ground, and hopefully if the season's good they get them back out. But what is doing to the actual ground is stripping it of clean out of its natural nutrients. Therefore, the natural biodiversity of detrivores and things like that are natural decomposers within the soil are no longer there, because it's not an environment anymore that supports that. And when you start to have this happen, you kill the soil, and once you've killed the soil, you therefore kill the prospects of growing good crops in that soil. And this is why you start to go down the line of adding chemicals, fixing the grounds and protecting the grounds with the pesticides that would sometimes thrive in the environments without the natural microorganisms within the soil. And this is just how we are moving forward over the last 20, 25 years, 30 years. These problems have become problems globally, and although we've got solutions short term to fix them, long term they're going to come back up and rear a real nasty head for us, unless we start taking action now to put these things right. And as you guys know, there is no short-term fix for these solutions. The other day I just briefly mentioned that our planet and the biodiversity on it has reduced by 2/3 over the last 10 years. Can you imagine that? 2/3 of the species has disappeared from our planet. Fish stocks are at all-time lows. We're struggling to keep and maintain 7 billion people on this planet, and proof of that is the starvation that's taking place around the world. Hundreds, if not millions of people are in some countries starving to death as we speak, and that is just piss poor management of the resources on this planet, and failing to look at the data analytically and make predictions to avoid some of the most severe problems that not just human beings are going to face, but the entire biodiversity on this planet. It's a failure, guys, by the stewards on this planet with the intelligence, and that book falls down to me and you and the rest of us. We can scream from the top of our voices and it doesn't seem to go noticed. We see these crazy organisations like Extinction Rebellion come along and get it completely wrong about CO2. We're destroying the earth, and if we don't reduce our emissions down to zero within a certain amount of time, people will die. No, people are going to die, and they're going to die in larger numbers if we don't reverse what we're doing. But it's nothing to do with CO2, because it would be impossible from us at this point, and let's just say for argument's sake CO2 was at 422 parts or 420 parts per million. That's probably in the mean line at the moment. As we've seen at the observatory, it fluctuates from about 400 to 450 at some days. Let's say it's at 425 throughout the year constantly. It doesn't make any difference. Even if we doubled it to 1,000 parts per million, the vegetation's only going to thrive on this planet. It's not going to affect us. I've showed you guys the levels of CO2 in my living room compared to outside in the atmosphere. It's a lot safer when you go out your front door, trust me. If you've got a couple of people breathing and respiring in your living room, those parts per million can go up to 1,500 parts per million. Tell me something. You don't feel lightheaded in an environment of CO2 of 1,500 parts per million, but I guarantee you this, if you've got houseplants in that environment, they're going to be putting their little leaves up and saying, great stuff, we love this, it's perfect. And that's why these industrial greenhouses, inject CO2 into the atmosphere. So, what does surprise me is that they can, for some reason, these organisations like Extinction Rebellion drive up numbers and drive up emotions in people enough to get them following it. Can you imagine if we had that sort of drive for some of the other things, like, if we was to try and push the governments to do more on magnetic reversal and relay that information back to the public? That, it'd be a sign of change in the right direction, I believe, but they don't. And I don't think it's even on the government's local agenda to get involved in such things. They leave it to the so-called professionals, and we end up with a situation which I've come across so much in my life. I call it in-house syndrome. That means if the information doesn't come from a specific body that's recognised for its activity in geophysics, geomagnetism, or etc., whatever the field is, then it shouldn't come from anywhere else. And if it does, you shouldn't take any notice of it, because they are not the leaders in the field. Well, we have shown our subscribers over the last couple of years that we can beat our competitors in this field, like NASA and the European Space Agency, to the table with information with regards to changes in the geomagnetics of this Earth. We've done it a couple of times. We've done it well before they have had to, produce a new world magnetic model and diagram for people to follow for the next couple of years. We came out and told people that there were some unusual activity at the beginning of this year with relationship to what was taking place with the magnetic poles. We were seeing what we described as magnetic jet activity, where we was getting very short spikes during the readings, and it was an indication that something was definitely going on. And we made the announcement, and then NASA came out and made the announcement and told everyone that we'd have to update the world magnetic model. But what NASA hasn't come out and said, they have showed the videos in their little models, but they've not said, look at this, what's happening over Canada. Look how fast the dissipation of the intensity of magnetism over that region is depleting. And why has the pole started to migrate in the first place? Hold on a minute. If we look over what's taking place in Russia, we can see this increase in intensity, magnetic intensity. Maybe that is why the dipole is being stole from Canada and being brought across the northern hemisphere towards the direction of Russia. They have never came out and told you this. Not one person from any of these organisations has sat down and told you that this is the case. This information came from one place on the entire internet. That was the Mavstar Observatory. That's why we are different from anybody else. That shows you, if we're coming out and telling people about this, and these organisations aren't saying nothing about it, it's either that they didn't notice it, they're not aware of it, or we could be conspiracy theorists and put our tin hats on and say they're covering it up. One thing for sure is that they didn't, to start with, talk about these specifics that we do on this channel. We're covering the South Atlantic Anomaly, and soon we're going to have equipment in the South Atlantic Anomaly. Trust me, it will come. Someone will step forward and they will take our muon detector and our magnetometer on, and we will have our, completed set. We'll have one in the highest region, one in the lowest region, and not just that, we'll have also magnetometers in them regions as well, and we'll know what's going on with regards to radiation. We'll answer that question first and foremost for you of what to expect when the magnetosphere depletes even more. The reason for that is the South Atlantic Anomaly comes with a punch of about 22 microteslas, as opposed to in some of the higher regions on our planet that has about 55 microteslas. And we get an idea what happens in a region of low intensity compared to a region of high intensity, and that gives us an idea of the level of radiation in regions where the poles and where the magnetosphere drops to low levels. and that gives us an indication of what to expect with cancer rates and stuff like that. I would love to focus more specifically on Brazil and have a look at what the rates of cancer are and try and figure out why they are. You know, you've got to have a lot of information on various other things. I mean, we know that the level of life over there isn't to the same standards as what we've got, so healthcare is not going to be that great, so people could be dying as a reason due to low and poor healthcare. And not only that, they suffer with a lot of other things because it's not a very rich country. So, you know, there is a lot you know, that we do at this observatory, and you know, we try and cover all the anomalies on this observatory as well that are taking place, like volcanoes. Another subject perhaps tomorrow, because I know this is running on a little bit long, but perhaps we should go back to looking at you know, the levels of volcanic eruptions taking place, because I don't know whether you looked at the Earth Health at a glance. There was a drop again, and we've seen a drop in the last 2 years of one third of those you know, erupting volcanoes disappear completely, which is quite a large amount, guys. I think it's something that we should be concerned with, because you know, this gives us an indication of what's taking place in the core of our Earth. We've got an active core, we've got active erupting volcanoes. If we don't, then you know, we're in big trouble, because you know, this is one of the noticeable things that stopped on Mars. And you know, after all, we are 500,000 years overdue a magnetic reversal as well. So you know, I've always said this, and again, this is not coming from mainstream organisations. They're not mentioning the reduction in active volcanoes. They're not also mentioning what happened too much with regards to Mars, because I guess they don't want to cause alarm. And they also don't mention that the poles are overdue by 500,000 years, and put all this in a, you know, a scenario which is obviously there. The scenario is there. You know, when you've got a reduction in volcanic activity, you've got poles that aren't reversing frequently like they used to on every account 350,000 years or thereabouts. You know, it looks like we're aiming to the same place where Mars is right now. No core activity, or very little. No magnetosphere, and therefore no water on its surface, no atmosphere. You know, these are things that are on, you know, the line. We have to take these into consideration, because these are the risks this time round with this geomagnetic reversal. So I think I've gone on a little bit more than what I should have. Guys, don't switch off at the moment. I'm going to mention the links. There's a link on our website. We get 7,000 people visit our website. And in the last week, out of those 7,000 people, only 3 of those made a donation on that website, and we can track it now because we're using a different location to PayPal for those funds to go, so we know what's going on with the website activity compared to YouTube. And if I can just encourage a few more people to become patrons and, you know, make those one-off PayPal donations to this observatory, that would be amazing. But we are in one of the worst case scenarios in this climate that we're in with COVID-19. I know, and I sympathise with a lot of you people, as you know, that it's difficult times for us all. But I really do cringe at the prospect of losing all the work that we've put in right now. It would be a great loss, in particularly at this time, because we are so close to an event that this channel is dedicated to, and it would be catastrophic, I believe, if people didn't get access to the real information which is taking place geologically on our Earth. The only way we can do that is to keep it funded, and it doesn't need to be massively funded, guys. We're not trying to raise millions of pounds for this. We're just trying to keep our heads above water. I'll be happy with that. And you know, I'll continue doing what I have to do at this end in order to make that happen. I mean, we probably sit on you know, if we was to buy the equipment, £500,000 worth of equipment to do our operation, if NASA was to try and do it, it would be in the tone of millions. So we do have assets here at the moment. Let's keep them, and let's keep it funded, guys. And the only way we can do that is by asking the public and not corporations for that funding. and therefore we can keep directing the information to you guys unbiasedly. And if we was to have corporate funding, we'd also be told what we can and can't put out. That in fact they would own us, and they don't at the moment. This is a private observatory, so it's pretty unique. Just needs a bit of funding. Okay, I hope you enjoyed the video. We'll be looking at volcanic activity and how that can change our planet tomorrow, and hopefully you'll join me then, and I'll say what I usually do. Links down there for the support. You have an amazing day. I'll be back tomorrow, and as always, bye for now.